Welcome to
Welcome.
the AI Security Summit 2025 series of podcasts. The Global AI Security Summit 2025, scheduled for London this November, will focus on redefining security in the age of AI. The summit brings together industry leaders, researchers, startups, major security players, policymakers, and, well, everyone involved, really, to surface the importance of security in agentic AI. Today, we're unpacking some fascinating insights from Google Cloud on exactly how they approach securing these emerging AI agents. Okay, so let's dive in. We've all heard tons about AI lately, right? But AI agents, they seem like a distinct evolution.
We really are.
They don't just think, they act. So maybe let's start there. What exactly are these AI agents, and why do they suddenly demand this completely new way of thinking about security?
Yeah, that's a great starting point. What's truly fascinating here is how AI agents take these powerful foundation models and add this unique layer of autonomy. Think of them as systems that aren't just processing information you give them. They're actively using tools, they're devising complex plans, and crucially, executing actions to achieve specific goals you've set for them.
Okay.
So they're moving beyond just answering questions to actually doing things, either in the real world or, within your digital systems. And this newfound capability, well, it fundamentally reshapes how we interact with technology. And it definitely raises some pretty significant questions about control and safety.
So it's really not just about what the AI knows anymore,
Exactly.
but what it does and the potential impact, the real-world impact of those actions.
Precisely.
And this is where it gets, well, incredibly important, I think. This autonomy sounds powerful, absolutely. But it also carries a significant amount of risk. The source material we looked at emphasizes that classic line: great power comes great responsibility.
A very apt quote here.
So for the developers building these things, for the security practitioners trying to protect them, what kind of responsibility are we actually talking about when these agents can act so independently?
Well, that really leads us straight to the critical question, doesn't it? How do you ensure that an agent's behavior consistently aligns with what the user actually intends?
Right.
And maybe even more importantly, how do you prevent any unintended or potentially harmful actions? The core challenge here is that our traditional security paradigms, the ones designed for static software or even the more general non-agentic AI,
Yeah, the old playbook.
right,
So-
they often just lack the contextual awareness needed for these dynamic systems. They can end up being too restrictive, which kind of stifles the agent's utility.
Defeats purpose.
Exactly. Or worse, they might entirely miss subtle threats. And just relying solely on the AI model's own judgment for security, that's also proving inadequate.
Especially with things like prompt injection, I imagine.
Absolutely, especially with vulnerabilities like prompt injection, where just a cleverly crafted input can completely hijack the agent's purpose. So this isn't just an extension of existing security practices. It really necessitates a dedicated new field of study focused specifically on securing these agent systems effectively.
Okay, it sounds like a genuinely complex problem that needs some really foundational thinking. And Google Cloud has proposed 3 fundamental principles for building secure and trustworthy AI aging systems. Can you walk us through those core ideas? What do they believe should guide this new field?
Absolutely. And these principles, they provide a clear, actionable foundation, really, for anyone building or deploying these agents. They're designed as sort of universal guardrails. So first, agents must have well-defined human controllers.
Okay, human controllers.
Yeah, and this isn't just about having an off switch. It means there needs to be clear human oversight, mechanisms to ensure the agent can distinguish between genuinely authorized user instructions and any other inputs, especially potentially malicious ones. You need to know, fundamentally, that you are in control, and the agent needs to know who is in control.
Got it. Control is key. What's the second principle?
Second, agent powers must have limitations. This is absolutely crucial.
Limitations. Makes sense.
It's all about carefully limiting what an agent can actually do and what resources it can access. And importantly, these limitations need to dynamically align with the agent's intended purpose and your specific risk tolerance as the user or organization.
So it's tailored.
Exactly. Think of it as the principle of least privilege, a cornerstone of cybersecurity for decades.
Right. Give it only what it needs.
Precisely. Now applied directly and dynamically to AI agents. It's that essential boundary setting that prevents an agent from doing more than it absolutely should, even if it's intelligently trying to achieve a goal.
Okay, human control, limited powers. Well, a third.
And third, agent actions and planning must be observable. Transparency and auditability are just non-negotiable here.
Observability, so seeing what it's doing.
Exactly. This means robust logging, clear characterization of every single action an agent takes, and even insight into its internal planning process, if possible. Basically, if you can't see what an agent is doing or understand why it's doing it, you simply can't secure it.
Makes sense. You can't protect what you can't see.
Right. This observability is what allows you to detect rogue behavior early, debug issues when things go wrong, and ensure compliance with policies.
Those sound like incredibly solid, almost common sense principles.
Mm.
But implementing them in practice
Mm-hmm.
for something as complex and, well, dynamic as an AI agent,
Mm-hmm.
that must be a huge challenge.
Oh, absolutely.
So what does this actually mean in a real-world security architecture? Google advocates for something they call a hybrid defense-in-depth approach. Can you explain what that hybrid model looks like, combining, you said, traditional and these newer reasoning-based measures?
That's precisely the next logical step, yeah. The principles lay the groundwork, but the real engineering challenge is how you implement them in a resilient way. And that's where Google's hybrid defense-in-depth idea really comes into play. This approach is key because it aims to create layered defenses.
Layers, okay.
Layers that can prevent catastrophic outcomes while still preserving the agent's usefulness and flexibility. You don't want to lock it down so much it can't do its job. So it cleverly blends the strengths of both traditional deterministic security controls, the kind we're familiar with in software engineering.
Firewalls, access control, that sort of thing.
Kind of, yeah, but applied differently. And it combines those with dynamic, reasoning-based measures that actually leverage the AI's own capabilities for defense. The goal is really to secure agents using both classic security techniques and techniques native to AI itself.
And they break it down into two distinct layers, right? That layered approach makes a lot of sense for building resilience. Let's start with the first one.
Exactly. So layer one focuses on traditional deterministic measures. This is where you find things like runtime policy enforcement.
Runtime policy.
Yeah, think of these runtime policy engines as external, highly vigilant guardrails. They actively monitor and control the agent's actions before they get executed based on predefined hard rules. These engines often use something called action manifests.
Action manifests. What are those?
They're essentially detailed descriptions, metadata, if you like, about the security properties of every single action an agent could potentially take. So this includes things like what dependencies an action has, its potential effects, any authentication it requires, the types of data it handles. It's quite granular.
Okay, so it's like a rule book for each action.
Pretty much, yeah. Let's take an example. Imagine an agent that's designed simply to deploy a virtual machine in your cloud environment.
Okay.
Its action manifest clearly states its purpose and the only actions it's allowed to perform. Now, let's say a prompt injection attack somehow tricks the agent, makes it interpret a malicious input as an instruction to, say, delete all databases.
Well, that's bad.
Very bad. But the runtime policy engine would see this delete all databases action request coming through. It checks the manifest for the VM deployment agent and sees, nope, that action is not authorized here.
And blocks it.
And blocks it immediately before any damage is done. It's a very concrete, rule-based barrier, like a bouncer at a club checking an ID and a guest list very strictly.
Right, that makes sense. A hard stop for known bad actions.
Yep. What about the second layer, then, the reasoning-based one?
So layer 2, in contrast, involves reasoning-based defense strategies. This layer actually uses the AI model's own reasoning capabilities to enhance security internally.
Interesting, using the AI to protect itself.
In a way, yes. Techniques like adversarial training, for example, that's where the model is deliberately exposed to and trained on malicious inputs during its development, so it learns how to recognize and resist them.
Ah, like inoculating it. Kind of, yeah. Or using specialized AI models that act almost like internal security analysts, constantly evaluating inputs and planned actions. These help the main agent distinguish legitimate commands from malicious ones. The goal here is to make the agent itself much more resilient against sophisticated attacks like subtle prompt injections or attempts at data theft, even things like model theft. It's about teaching the AI to be its own first line of defense, adding this crucial layer of intelligent self-protection.
Wow, that's a powerful combination. It really sounds like a recognition that, neither method alone is going to be enough for the complexity of these agents.
It's absolutely not.
You can't just rely on hard rules because agents are too dynamic, but you also can't just rely solely on the AI's judgment because it can be tricked.
That's the core insight. It truly takes both.
And they emphasize that each of these layers should probably have its own layers of defense within it too, right? Creating a really multifaceted security posture.
Precisely. It's defense in depth taken, you could say, to the next level for AI. So, for instance, within that reasoning-based layer, you might combine model-based input filtering with adversarial training. Now, while these techniques significantly reduce risks like prompt injection, they might not completely eliminate them 100% of the time.
Right, no silver bullet.
No silver bullet. Similarly, while these reasoning defenses make data theft harder, they still absolutely need to be bolstered by traditional controls on the other layer, like rule-based or algorithmic threat detection monitoring data access patterns. It's truly about building layers upon layers, ensuring that if one defense is somehow bypassed, another stands ready to hopefully catch the threat.
Okay, so given how complex this all sounds, the source material points out, as you mentioned, that traditional security is insufficient. And just relying on the model's judgment isn't safe either, especially with things like prompt injection. It highlights two major risks with AI agents that seem both more likely to happen and potentially more damaging if they're ignored. What are those critical risks that people really need to be looking out for?
Yeah, if we connect this back to the bigger picture of actually deploying these agents, these are the critical vulnerabilities we absolutely need to prioritize. The first one is rogue actions.
Rogue actions sounds dramatic.
It can be. These are basically unintended, harmful, or policy-violating behaviors that an agent might exhibit. And they can stem from several factors. There's the stochastic nature of the underlying models, that inherent randomness or variability in their output. There's the emergence of unexpected behaviors as agents interact with complex environments, things you didn't predict. And then there are the inherent challenges in perfectly aligning agent actions with your original intent.
And prompt injection fits here.
Definitely. Prompt injections are a particularly significant vector for inducing these rogue actions. That VM deployment example we talked about, that fits perfectly here. An agent instructed for one task could be manipulated into performing a completely different harmful one just because of a cleverly crafted input it wasn't designed to handle.
Okay, rogue actions is one. What's the second major risk?
The second major risk is sensitive data disclosure.
Data leakage.
Exactly. This involves the unauthorized revelation of private or confidential information by the agent. Imagine an agent that has legitimate access to customer data, maybe to generate sales reports or something.
Okay.
If it's not secured properly, it might inadvertently retain some of this sensitive data in its short-term memory or context window.
Right.
Then a malicious user, or even just an unaware user asking the wrong follow-up question, could potentially coax the agent into inadvertently disclosing some of that retained data.
Wow, yeah. That's subtle.
It's very subtle, and it's a huge concern for privacy, for compliance, for maintaining user trust. It's particularly insidious because the agent isn't necessarily trying to be malicious. It might just be following what seems like a valid instruction based on the information currently available to it.
Okay, so specific risks like rogue actions and data disclosure. But beyond those, what are the inherent challenges that just make securing AI agents so fundamentally difficult? It sounds like there's something about their very nature that poses a hurdle.
You're right. There are definitely structural challenges here. The source outlines 4 core ones that really define the complexity of this space. First, unpredictability. This comes directly from their non-deterministic nature. AI models don't always behave the exact same way every single time, even if you give them identical inputs. This inherent variability makes it harder to guarantee consistent security outcomes.
A bit of a moving target.
Exactly. Second, emergent behaviors. As these agents get more complex and interact with more tools and data and environments, they can develop behaviors that weren't explicitly programmed or even foreseen by their creators. This makes predicting all possible attack vectors really challenging. Third, autonomy in decision-making. Unlike traditional software that just strictly follows predefined code paths, these agents can make choices and execute actions independently, dynamically responding to situations. This independence, while it's their great power, makes traditional rigid control mechanisms less effective. And finally, alignment issues. This is a big one. Just ensuring the agent's actions truly match your intent. Bridging that gap between what you want the AI to do and what it actually does in all circumstances, that's a fundamental, ongoing challenge that has huge security implications.
Okay, given all these complexities, these challenges, unpredictability, emergence, autonomy, alignment, let's bring it back to the practical side again. What are the practical security considerations that Google's hybrid approach specifically addresses? And maybe more importantly, how can organizations start implementing these ideas right now? What are the actionable takeaways?
Right, making it real. The recommended hybrid approach, thankfully, does touch on several critical areas for practical implementation. It offers some very concrete steps organizations can take. First, it emphasizes robust agent plugin user controls. This means things like requiring human confirmation for critical or irreversible actions. No agent deleting the production database without a human saying yes.
Good call.
Also, having a clear, verifiable distinction between what constitutes genuine user input versus other data the agent might encounter, and critically, having verifiable sharing of agent configurations so you know exactly what your agent is set up to do and can audit that easily.
Okay, strong user controls. What else?
Then there's agent permissions. We touched on this with the principles, but in practice it means strict adherence to least privilege, give agents only the bare minimum permissions they need, confine their actions to their specific domain, severely limit broad permissions, and always allow for user authority revocation the ability to easily turn off or restrict an agent's access. It's fascinating, really, how traditional, almost 1980s style security control, like granular permissions,
Yeah, basic stuff.
delivers such incredibly high value for securing these bleeding edge 2020s AI agents. It's a foundational security concept that proves its timelessness again and again.
Interesting how the old basics still apply. What's next?
Next up is orchestration and tool calls. This is about the intricate relationship between the AI agent and the external tools or APIs it uses. Sometimes this is called actions as code.
When the agent calls out to other services.
Exactly. This presents unique risks. So robust authentication and authorization for those tool calls are crucial, and something called semantic tool definitions.
Semantic tool definitions.
Yeah, it means explicitly defining not just that an agent can use a tool, but what the tool does, what its inputs and outputs are, and what its security properties are. This helps the agent and the policy engine understand the boundaries, ensuring it only uses tools in ways it's truly intended and authorized to.
Okay, managing the tools it uses. Makes sense.
Then there's agent memory. The data stored in an agent's short-term or long-term memory can become a significant vulnerability.
Right, like the data disclosure risk you mentioned.
Precisely. It can lead to persistent prompt injections where a malicious instruction kind of gets stuck in memory or information leakage over time. This needs careful, secure management, strict data retention policies, maybe memory compartmentalization, robust encryption where appropriate.
Okay, memory management. And the last one.
And finally, response rendering. This might seem simple, but safely rendering the AI agent's outputs into user-readable content, like displaying it on a web page, is vital.
Why is that?
Because this is where classic web vulnerabilities like cross-site scripting, XSS, can pop up again. If the agent's output contains malicious code and it's rendered directly without sanitization.
The agent's response could attack the user's browser.
Exactly. So ensuring the agent's output itself doesn't become a vector for attack is paramount. Basic web security hygiene, but applied to AI outputs.
That's a really comprehensive checklist for anyone building or deploying these systems. User controls, permissions, tool calls, memory, response rendering. Lots to think about.
So what does all this mean for the ongoing effort? How do we ensure these measures actually remain effective against the constantly evolving threats we're seeing in the AI space? It feels like a moving target.
It absolutely is a moving target. And that leads us to the crucial question. How do we ensure continuous assurance? Because the threat landscape for AI agents is incredibly dynamic. Continuous effort is essential. There's no set it and forget it here. This includes rigorous regression testing every time you update the model or agent logic, variant analysis to understand how small changes might introduce new vulnerabilities, regular red teaming where you have ethical hackers deliberately try to break the system.
Proactively looking for holes. Actively looking, plus collecting user feedback on any unexpected or weird behaviors they notice, and actively engaging with external security research programs, bug bounties, things like that. All of these are critical to ensure your security measures remain effective against threats that are evolving literally day by day. It's really an ongoing journey of adaptation and vigilance. Google Cloud, for instance, they mentioned they already offer controls in their agent space platform that align with these guidelines, things like authentication, authorization, model safeguards, posture assessment tools, robust logging and detection capabilities, all designed to help organizations try and stay ahead.
And for anyone listening who wants to really dive deeper into Google's specific approach, all the technical details, they've published a comprehensive research paper on this, which sounds like it would be well worth exploring. Well, the rise of AI agents is truly transformative, isn't it? It brings incredible utility, incredible potential, but it also clearly demands a completely new and proactive approach to security.
No question about it.
Understanding these core principles, human control, limitations, observability, and this layered hybrid defense strategy, plus being aware of the inherent risks. It all seems crucial for anyone engaging with this technology. And maybe as AI agents become even more ubiquitous, the deepest question isn't just how we secure them, but perhaps who we fundamentally trust to define their purpose and police their actions in the first place. What does true human control really look like when an agent can devise its own complex plans? Something to think about. We hope to see you in November at the AI Security Summit 2025. We will be there. Don't miss it. Thank you for listening to the AI Security Summit 2025 podcast.